So our friend Bob is moving at a constant speed upward in his car, and it's on an incline of 30 degrees. The mass of his car is 1500, and we're trying to find the forces on his car, the coefficient of friction, and the force needed to bring his car to acceleration of 3.25 meters per second squared. So we first have to denote the axes, since that changes because of the incline. And then we can draw a dot to represent the car, free body diagram. We know that the force of gravity is equal to 15,000 because it's the mass times the acceleration of gravity, which is 10. But we note that our axes, so we have to change this and separate into x and y components. This is our degrees because it's the same as up here. And we have 7,500 newtons because 30, 60, 90 triangle, and calculations show us that this is 12,990.38 newtons. And since we're moving at a constant speed, the other forces have to compensate and it'll be at equilibrium. So force forward has to be 7,500, compensating for the force of friction. And the force up, which is the normal force, has to compensate for the gravity y value. So the normal force is also 12,990.38 newtons. Next, we can use this to find out our coefficient of friction. And so our formula is friction equals coefficient of friction times normal force. We know normal force and coefficient of friction up here, so you can pull those values down and use algebra to solve. So 7,500 equals coefficient times 12,990.38. So we can use algebra. Coefficient of friction equals 0.577. And so that we have those two pieces. Now we can use one of Newton's laws. Net force equals mass times acceleration. Acceleration is 3.25. Mass is 1500. Note that in real life, this wouldn't actually be calculated because the car needs more friction going backwards to compensate. However, this is the reason why you can't really accelerate on like straight ice and like run on ice to accelerate there, because there's not as much friction. So calculate 4875. So this will stay the same force of friction. So then we have to change friction force going forward, apply force on the car. 7,500 plus 4875 equal to 12,375. And so that's the force needed to make the car go forward at acceleration of 3.25. Thank you.